Bismillahirrahmanirrahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this particular video I'm going to solve a few past paper questions from International A-Level Edexcel P3 Pure Mathematics 3, and the topic is basically differentiation. And here we have a past paper handout, and this is question number 8 of the handout, which is January 2008 C3 question number 2. Okay, so the question says that a curve C has equation y is equals to e raised to the power of 2x times 10x, where x is not equal to 2n plus 1 times pi over 2. This means that x is not an odd multiple of pi over 2, because when x is an odd multiple of pi over 2, so the function of 10x is undefined. The graph of 10x will have vertical asymptotes at those points, because at those points cos x is basically equal to 0. So this is basically a brief way to read this domain. Okay, that x is not equal to an odd multiple of pi over 2. So the requirement of part A is to show that the turning points on the curve occur when 10x equals minus 1. So what we need to do, we need to differentiate the equation of the curve, and we will get the dy over dx function, and we will equate dy over dx with 0. Okay, so first thing first, what we know, the fact is that equation of the curve is given to us in the form of y is equals to u times v, where u is also a function of x and v is also a function of x. Okay, so u is basically the exponential term, which is e raised to the power of 2x. So when we differentiate u with respect to x, we get u dash. So this will be 2 times e raised to the power of 2x. Okay, so basically the concept behind is that when e raised to the power of kx is differentiated, so this gives you e raised to the power of kx as it is, and then multiplied by k. Okay, and we can also say that when e raised to the power of fx is differentiated, so this gives you e raised to the power of fx and then multiplied by f dash x, where fx can be any function in terms of x, either linear or non-linear. Okay, so this is basically the basic concept behind this. So I've just mentioned this, the standard form over here. So when u is equals to e raised to the power of 2x, so u dash is 2 times of e raised to the power of 2x. And then v is equals to 10x. Okay, so v dash is basically sec square x. All right, the basic concept is that when you are differentiating this trigonometric term, which is 10x, okay, so you get this term sec square x. All right, and a form which is given to you in the formula booklet is that when you differentiate 10kx, so you get k multiplied by sec square kx. Okay, so this basic form is proved by the formula of the quotient rule. Okay, and this comes from chain rule. And through this concept, we can also establish another chain rule form, is that when we differentiate tan fx, okay, so what we get is f dash x multiplied by sec square fx. Okay, so this is basically the whole idea behind this. So I hope you have covered these basic concepts before attempting the past paper questions. All right, so you must be well known with all of these forms, with all of these derivatives before actually attempting any past paper question. So basically the concept is that when equation of the curve is given to us in the form of y is equals to u times v, so dy over dx is equals to uv dash plus vu dash. Okay, you need to remember this particular sequence, uv dash plus vu dash. Okay, so you need to remember the arrows over here. All right. So basically, the formula for differentiating by product rule is not given to you in the formula booklet of International A-Level Edexcel Maths. So you need to remember this formula. Okay, and here we have a simple sequence, uv dash plus vu dash. All right, so we are going to find the dy over dx function. So u times v dash, this means e raised to the power of 2x multiplied by sec square x, and then plus vu dash. So v is multiplied by u dash. Okay, and we need to equate the dy over dx function with 0 in order to get the turning point. We don't need to actually find the turning point, the stationary point. We just need to show that uh, in order to get the stationary point, in order to get the turning point, you need this equation. The required equation is tan x is equals to -1. Okay, so we have the equation in this form. And now we can say that if we take e raised to the power of 2x as common, we are left with this expression inside, which is sec square x plus 2 tan x. And this whole thing is equal to 0. So first of all, when we equate e raised to the power of 2x with 0, so this equation cannot be solved, okay, because when you convert this index form into a logarithmic form, so the argument of the logarithmic term will get 0 and this will be undefined. So here we are just going to mention that there is no solution. Okay, we have a basic index form, which is, let's say, on the left hand side you have 0 and this is equals to e raised to the power of 2x. So when you convert this index form into a logarithmic form, so base of the index form actually becomes the base of the logarithmic form. Okay, and this will be equated with 2x. So this thing will be undefined because argument of the log cannot be 0. Okay, so you don't need to mention these steps. Only this thing is fine that you have mentioned no solution. All right. And then what we are left with, the other factor, which is sec square x plus 2 tan x is equal to 0. And as we know, a basic identity in P3 that 1 plus tan square x is equivalent to sec square x. Okay, so in place of sec square x, I'm going to write this identity over here, 1 plus tan square x, and then we have plus 2 tan x, and this whole thing is equal to 0. So tan square x plus 2 tan x plus 1 is equal to 0. So here we have a perfect square, as we can identify that this is basically tan x plus 1 whole square, and this is equal to 0. All right, or you can just perform the factorization in steps as well. So we can say that we are factorizing this expression. So 2 tan x is broken as tan x plus tan x and then plus 1, and this whole thing is equal to 0. So taking tan x as common, multiply by tan x plus 1, taking 1 as common, multiply by tan x plus 1, which means tan x plus 1 whole square, and this whole thing is equal to 0. So here we have already identified the fact that this is the form of perfect square, meaning this is the expansion of tan x plus 1 whole square. Okay, so mentioning this thing would be sufficient as well. Okay, this was just some additional explanation. All right. So far we have achieved this thing. And when we take a square root on both sides, so we are going to say that when a square is removed, so tan x plus 1 is equal to 0, and therefore we have shown our required form that tan x is equals to -1. Okay, so this was the requirement of part A. All right. So now let's move on to part B. The requirement of part B is to find an equation of the tangent to curve at the point where x is equal to 0. Okay, so what we have found the dy over dx function. Okay, so we need to find the value of dy over dx at x is equal to 0. So I'm going to substitute this x is equal to 0 into the dy over dx function, which is, I can use this particular form where I've taken e raised to the power of 2x as common. All right. So e raised to the power of 2 times 0 multiplied by sec square 0, meaning sec 0 is squared, plus 2 tan 0. Okay, so e raised to the power of 0 is basically 1, and this is 1 divided by cos 0 is squared. Okay, and then 2 tan 0 is basically 2 times 0, because the value of tan 0 is 0 and cos 0 is basically 1. So basically 1 times 1, the gradient is equals to 1, meaning dy over dx is equals to 1, meaning the gradient of the tangent is equals to 1. All right. And when x is 0, so we need the corresponding value of y as well. And for that purpose, we are going to substitute x is equals to 0 into the equation of the curve. And as we can see that when x will be 0, so tan 0 will be 0. So y will also be equal to 0. Okay, so y is equals to e raised to the power of 2 times 0 multiplied by tan 0. This will also give you 0. Meaning the equation of tangent, when we are going to find the equation of tangent, so the line is having a gradient of 1 and it passes to the point origin, which is 0 comma 0. Okay, so this is basically y is equals to mx, where m is 1, so y is equals to x will be your answer. Okay, y minus y1 is equals to m multiplied by x minus x1, so y is equals to x is your answer. Either you can write y is equals to x, or you can say y minus x is equal to 0. Both are fine. All right, so this was the simple requirement of part B. Okay, so here we attempted this particular question, January 2008, C3, question number 2. This is question number 8 of the handout. So now let's move on to the next question. So now let's move on to the next question, which is question number 9 of the handout. This is June 2008, C3, question number 1. Okay, so the question says that the point P lies on the curve with equation y is equals to 4 times e raised to the power of 2x plus 1. And then it says that the y coordinate of P is 8. Find in terms of ln2 the x coordinate of P. Okay, this is the requirement of part A. So what we know the fact is that the y coordinate of P is 8. So I'm going to say that 8 is equals to 4 times e raised to the power of 2x plus 1. So therefore I can say that e raised to the power of 2x plus 1 is equals to 8 divided by 4, meaning e raised to the power of 2x plus 1 is equals to 2. Okay, so now I can take ln on both sides. I can do this thing as well, or I can just convert this basic index form into a logarithmic form. Okay, since P2 you are studying the fact that when you have a basic index form in this form, that y is equals to a raised to the power of x. So basically a is the base of the index form. So when index form is converted into a logarithmic form, so a becomes the base of the log. So I can say that log with the base a argument y is equals to x. I can say log with the base a, or I can say log to the base a. Both means the same. My usual way of describing this is that log with the base a argument y is equals to x. Okay. So basically when 2 is equals to e raised to the power of 2x plus 1, so we can say that the base of the index form is e. Now this will become the base of the logarithmic form. So I can say that log with the base e argument 2 is equals to 2x plus 1, and log with the base e is basically ln. So ln 2 is equals to 2x plus 1, and therefore x will be equals to ln 2 minus 1 completely divided by 2. Or you can simply say x is equals to half is completely multiplied by ln 2 minus 1. This is supposed to be your answer. Okay, ln 2 is a separate term and minus 1 is a separate term. So you can write your answer in this particular form. Or you can say like something like this as well, that x is equals to half is completely multiplied by ln 2 minus 1. This is also fine. This looks more good. Okay, but both forms are fine. So this was basically the requirement of part A. We needed to find in terms of ln2 the x coordinate of P, meaning we needed an exact form over here. So basically my purpose over here is to explain the question in significant detail as much as I can in the time which I have available. So this is basically the whole idea. So this was a requirement of part A. Now in part B, what we need to find the equation of the tangent to the curve at the point P in the form y is equals to ax plus b, where a and b are exact constants to be found. So as you want to find the equation of the tangent, obviously we would need the gradient of the tangent, and for that purpose we are going to differentiate the equation of the curve. So equation of the curve is y is equals to 4 multiplied by e raised to the power of 2x plus 1. So basically, when we differentiate y with respect to x, so we get dy over dx function. So 4 is a constant term which is being multiplied by the exponential term. So we write 4 as it is. And then first we write e raised to the power of 2x plus 1 and then multiplied by 2. As I explained the form above. Okay, when we differentiate e raised to the power of fx, we get f dash x multiplied by e raised to the power of fx. Okay, in the same way, we can establish another form like this, that when we are differentiating e raised to the power of ax plus b, meaning e has a linear power. Okay, so we can say that e raised to the power of ax plus b as it is, and then multiplied by a. Okay, so all of this is established by using chain rule. All of these three forms are being established using chain rule. All right. So that is the concept. So when we differentiated e raised to the power of 2x plus 1, so first we write e raised to the power of 2x plus 1 as it is and then multiplied by 2. So when 4 is multiplied by 2, this becomes 8. So 8 times e raised to the power of 2x plus 1. This is the dy over dx function. So we are going to say that dy over dx at point P will be 8 times e raised to the power of 2 times half ln, half is completely multiplied by ln 2 minus 1 and then plus 1. Okay, so this means 8 times e raised to the power of what? 2 is completely multiplied by half ln 2 minus half and then plus 1. So 8 multiplied by e raised to the power of ln 2 minus 1 plus 1, which means 8 times e raised to the power of ln 2. Okay, so basically when you put e raised to the power of ln 2 in your calculator, you get 2. When you put e raised to the power of ln 3, you get 3. So when e raised to the power of ln x, you get x. So simply just e raised to the power of ln 2 is 2. So 8 times 2 is 16. So the value of dy over dx at point P is 16. Okay, this 16 is basically the gradient of the tangent. All right. So far we have achieved this thing. And what we know the fact is that point P is basically in an exact form. So point P is basically half is completely multiplied by ln 2 minus 1. So I can write half ln 2 minus half, comma, the y coordinate of P is 8. Okay, so I'm going to say that y minus y1 is equals to m multiplied by x minus x1. I'm going to use this form of the equation of the straight line. Okay, so I can say that y minus 8 is equals to 16 is multiplied by x minus half ln 2 minus half. Okay, so far we have achieved this thing. All right, so y minus 8 is equals to 16x minus what? 16 times half ln 2, meaning 8 ln 2. All right, and then plus 16 into half, because y plus, because this minus sign is multiplied by minus half. Okay, so 16 times half, this is supposed to be 8. Okay, and we need a particular form. Okay, so y is equals to 16x minus 8 ln 2 plus 8 plus 8. All right, so therefore y is equals to 16x plus 16 minus 8 ln 2, or you can say minus 8 ln 2 plus 16. You can write and you can write in any order. So this is basically in the form of y is equals to ax plus b, where a is basically the gradient, so a is 16 and b is basically this complete constant 16 minus 8 ln 2. So this is supposed to be your answer to part B. All right, so this was the explanation for this question. So in this video I've discussed these two questions. Okay, this one was question number 9, which is June 2008 C3 question number 1, and the previous one was question number 8, which is January 2008 C3 question number 2. All right, so I'll keep this video brief, and inshallah I'll be uploading more videos soon, so stay tuned to my channel. Thanks for watching. Assalamu alaikum.